So now we're going to look at volume and area and surface area as well. So these are all in your log tables. You have your surface area and volume of a cylinder, curved surface area, so that's like the face of it just there in the curved surface, and we've got the volume. On a cone you've got the curved surface area, which is pi or L. L is something you'll have to find using, well, if you're asked a question you'll have to find it using Pythagoras theorem if you're not given it already, or you might have to find the height using Pythagoras theorem, you might have to find the radius using Pythagoras theorem. But a lot of the time volume comes up of a cone. So for volume it's 1/3 pi r squared, so the radius squared and the perpendicular height. Then you've got a sphere, you've got the surface area. Again, sphere is just like a football, a 3D object. So surface area would be on the face of the sphere, and the volume would be, well, what makes it up, okay? How much room it takes up, that's the volume. A frustum of a cone, that's the lower part of a cone. You can use that formula there, but normally what happens on a question like that is we might be given a cone and we pretty much find the volume of the whole cone and then take away the little bit that's taken up on top. Or you can use this formula here. Okay, same thing. These two over here then, don't worry about them. Okay, so the next slide to look at. So we'll look at our next bit of the log tables, and that is on length and area. So a parallelogram, very rarely asked that. A circle or a disc, that's the length of the circle, so the circumference of the circle or the perimeter of the circle, and you've got the area. These are all 2D objects now. You've got a triangle over here, half times the base times the height, that's what that means. And then you've got an arc, if it's an arc of a circle, but no, that barely comes up really either. So now we look at some questions. I'm just going to show you one or two examples now using our formulas that we just had there a second ago. So let's say in example 1 here we have a sphere. There's a sphere. There's only one measurement we ever have in a sphere. At the moment there you can see we have the diameter of the sphere with the length all the way across, and we're asked to find its volume and its surface area. So for its volume, first of all, we'll go to our log tables. We'll find it's 4/3 pi r cubed. That is our formula. They're in your log tables. So 4/3, we're after being told pi is 3.14, so multiply by 3.14. And we're found, well, if the diameter is 16, the radius would be, of course, 8. Put into our calculator, and that's your answer there. If you're asked to get it in terms of pi, okay, so let's say it just said in terms of pi, well, we wouldn't use pi as 3.14, we just use the pi button on the calculator. So you'd end up with an answer pi. So you could have something like, let's say, 60 pi. Similarly with the surface area, so the face of it, 4 pi r squared, so 4 times 3.14 times 8 squared. So same thing, multiply them together, you get your answer. They're simple enough. Let's look at our second example there. You can see this is a sphere of radius 4 centimeters. It's dropped into a cylinder, partly filled with water. So think about like your bath at home, and once you get into the bath, of course, the volume of the water goes up, or the volume in the bath goes up. So when the sphere is completely submerged, the level of the water rises a certain amount. So this little certain amount that's after rising, that's still a cylinder. Okay, so our whole object is a cylinder, and this part here is also, it's a cylinder. Alright, so what we do here is, the volume of the sphere is equal to the volume of the cylinder. So this cylinder here is equal to the volume of the sphere. Okay, so in that case we make both our formulas equal to each other, and then we sub in what we know. So we don't know the height of the cylinder, we don't know this h here, but we do know its radius. Its radius is 8, so we can sub them in there, and you can see there, it's just a little, it's nearly like algebra there. We multiply everything together that we can. The two pi's will cancel out, so from the pi on each side like we have there, they will cancel out. Okay, so that's why down here it was 4/3 and then 4 cubed is 64. A squared is 64 times h. So well, here divide both sides by pi, it says there, then divide both sides by 64. So you can imagine this 64 is taken across over this side. Okay, so you're left with h is equal to 4/3, or h is equal to 1/3. There's so many examples we could actually show you on this, so I'm just going to show you another 2 here, and then I'm going to actually try one. Okay, there's just so many different shapes, as you can see, so many different ways you could ask. So here we're asked to find, of this cylinder here, to find the volume, the total surface area. So this is simple enough, kind of like the one we just had, actually easier than the one we just had. So the volume, first of all, would be, we just use our formula, look it up in our log tables, it's pi r squared h. Remember, always write down the formula for each one of these shapes. So if you're asked for the volume of a cylinder, well, write down the volume of a cylinder. Okay, write down the formula, because we could get marks for that. So if we go wrong later on, we could at least be on sort of a ledge mark. We're getting so far in the sum. Okay, so we can sub in pi 7, because the radius would be 7 instead of r, and h is 24. And we can multiply it together there, and we get 3696. We were told pi, of course, there was 22/7. Total surface area, something similar. There's for the curved surface area, and if you think of it, you have two circles, top and bottom. Okay, and it's the area of one circle is pi r squared, the area of two circles is 2 pi r squared. So we multiply it all together, add it up, 1364. So that's just a simple volume and total surface area. Okay, and now the volume of a cylinder. Okay, if the height is 8, find the length of the radius. Okay, so we're actually given the volume here. So this is like a backwards problem. So we're told what the volume is, so we know that pi r squared h is equal to 1232. So we fill in what we can. So we can fill in pi, because we're told what pi is. We don't know what r is, that's what we're going to ask to do, but we know what h is, we know what 8 is. So make it equal to 1232. So now we can bring across the 3.14 and the 8. So remember, if they're multiplied on one side, they come across and divide. Likewise, you could have just multiplied 3.14 by 8, found your answer, and brought it across and divided it into 1232. Same thing. So now r squared is 49.04, but remember, we have only found what r squared is, so we have to find what r is, so the opposite of squared is square root. You get 7.0, so it says the nearest centimetre in the question, so the answer is 7. So this next example here, we have a solid metal cylinder, a radius 5 and height 12. Here's the cylinder here, and what's happened is it's been melted down and recast as this cone. So in essence what they're saying here is the volume of the cylinder is equal to the volume of the cone. This has just been melted down, this cylinder, and recast as a cone. So what we're looking for here is we're looking for the height, we're looking for h. So we can write down both our formulas. We know that the cone is equal to the cylinder, and a cone's volume is pi 1/3 pi r squared h, and the cylinder's volume is pi r squared h. Next thing we can do is we can sub in our values. So 1/3 stays 1/3, pi stays as pi, or in our case is 10 for the cone squared. We don't know what h is, and the same thing on the other side, fill in what we know. Pi or is 5 squared times 12. So just have a quick look at that, and you can see we've pretty much just substituted everything into both formulas because the cone is equal to the cylinder. Now what we can do now is we can actually cancel out our pi's, because pi is common on both sides. You can imagine these are all multiplied here on the left hand side by each other, and we bring a multiply across, one's divide out, so literally just little rule of thumb, if there's something on the same side we can just cancel it out because they're all multiplied. So now multiply what we can on each side. Okay, so we multiply 1/3 by 10 squared, we get 33.33, and let's keep that going to h. We're going to make that equal to 5 squared is 25, by 12 is 300. So now to finish this one off, to get h on its own, h stays where it is, and we bring the 33.33 across, it becomes a divide of course. So 300 divided by 33.33, keeps on going, and we get h is equal to 9. And that's it done.